In this video, let's solve few problems based on the functions, whatever the topic we have discussed. Look at the first one. Find GOF and FOG. If f of x, the first one f of x is mod of x, g of x is mod of 5x minus 2. So let's start with the first one. See, we have f of x, mod of x, and g of x is mod of 5x minus 2. Right? Now, first thing what we have GOF, which is g of f of x, isn't it? So what do we have here? First, g of f of x is nothing but mod of x, correct? See, if you are going to get confused as to how to approach these kind of problems, what I would suggest is substitute this mod of x as another variable y. No matter what the function is, substitute it as y. Okay, and it's gonna make things a lot more easier. That's all. So this I will write it as g of y. Now, what is g of x given? So g of x is mod of 5x minus 2. Suppose if you take g of y, then what we are gonna get is that g of y is equal to mod of 5y minus 2, isn't it? But what is y? What did we substitute here? So we took y is equal to mod of x, isn't it? Substitute it back. That means you will get this to be mod of 5 times mod x minus 2. So this is going to give me g of f of x. This is the first part. Okay. Now in the same thing we have to calculate f of g of x. Correct? Now if you are calculating f of g of x, so this is f of g of x. So f of g of x is going to give me mod of 5x minus 2. Again, call this as y, in the sense y is equal to mod of 5x minus 2. Okay, this is going to give me f of y. See, f of x is mod of x. So f of y becomes what? Mod of y, correct? So this is going to give me mod of y. But what is y? 5x minus 2, including a modulus, correct? So we'll get mod of, again mod of 5x minus 2. See, when you have modulus like twice, we can just write it as 5x minus 2. Like, see, this value can never be negative, isn't it? It can never be negative. So instead of two modulus signs, you can just put one modulus sign. This is also fine. F of g of x, this is going to be the answer. Okay, now we'll do the second one. See the second part now. We have first, we'll do GOF, that is g of f of x, right? So g of f of x will be g of f of x is what? 8x cube, correct? Now again, so this will call it as y. So y is equal to 8x cube. So we get this as g of y, isn't it? Now what is g of y? G of y becomes y to the power 1 by 3, correct? So g of y is y power 1 by 3. Now what do we do? Substitute that y value. So this will give me 8x cube whole to the power 1 by 3, which is nothing but 2x. So g of f of x. So here you can write g of f of x is nothing but 2x. Alright, now let's do the next one, that is f of g of x. Now we have f of this one, isn't it? So this is nothing but f of g of x. So now what do we have? F of x power 1 by 3. So call this as y. So y is x power 1 by 3. So now what do we have? F of y, isn't it? So in place of x you have y. So what you can write this as f of y is equal to 8y cube. But what is y? X power 1 by 3. Substitute. 8 x power 1 by 3 whole cube. See, the cube and cube root cancels out. So the answer is going to become 8x. Or f of g of x is equal to 8x. So this is the answer for the first one. Now let's do the next one. See, the second one, you have f is from 1 comma 3 comma 4 to 1 to 5, and g is from 1 to 5 to 1 comma 3, and it is given by, so f is given, g is given. Now they're asking you what is g of f of x. So here this is g of f of x, right? Now what is f function? So if I write f of 1, f of 1 is nothing but 2. We already know this one. See, 1 comma 2. Likewise, if you take f of 3, you get 5. F of 4, we get 1, isn't it? Now what else do we know? So we also know that g of 1 is equal to 3, g of 2 is also equal to 3, and g of 5 is equal to 1. Correct? So we know this much. Now, what is g of f? So g of f of x. So first we'll take 1. That is g of f of 1. Fine. So when you take g of f of 1, so what is f of 1? 2. Isn't it? So we'll get this as g of 2. What is g of 2? 3. So g of 2 is equal to 3. Isn't it? So my first number is going to be 1 comma 3. This is the first ordered pair. Likewise, the next one, g of f of 3. So what is f of 3? 5. So you get g of 5. What is g of 5? 1. 1. So what do we get here? 3 comma 1. Correct? Now the last one, g of f of 4. This will be g of f of 4 is 1 and g of 1 is 3. So this will be equal to 3. So this is going to become 4 comma 3. So what can we say? So they're asking write down g of f. So g of f of x, this is equal to, so we'll write down. So first one is 1 comma 3. Correct? The next one is 3 comma 1. The last one is 4 comma 3. So this is the set g of f of x. That's all. That's the answer for the second question. Very simple, very direct. Fine. Now let's do the third one. See the third one. It's very direct and very easy. Let f, g and h be functions from R to R. That is set of real number to real number. Show that f plus g of h is equal to f of h plus g of h. Correct? So let's start with the first one. F plus g of h. Normal distributive property. There is no change whatsoever. Always use the normal distributive property. So this is going to give us. So basically what do we have? F plus g. So this of h, correct? So this one of h of x. Whatever that is, we have. So we generally taking it as x. That's all. No change. So this is going to become f of h of x plus g of h of x. This is nothing but FOH plus GOH, which basically we were trying to prove. That's all. There is nothing else in this one. All right. Likewise, if you do the second one, very, very easy. So f into g of h. Correct? So what do we do? F into g of h of x. Correct? Now, what do we get? F into h of x, or you can say f of h of x into g of h of x. This is nothing but FOH dot GOH, which basically is what we are trying to prove. Understood? So, the three questions, whatever you have done so far, these three, it's nothing but the different types of problems what you can expect from the composite functions. Now, in the next video, we'll discuss about another topic.